Moving ahead. Now apply all of those characteristics which we have seen with respect to the Earth's surface or with respect to the lithosphere and the propagation of energy in all the directions. Pay attention guys, you have to focus here, because if this slide or this part would going to miss, never going to understand the interior part of our. All right, I hope you remember the characteristics of P waves and S waves. I told you it can, P wave can pass through all mediums and S wave can pass through solid only. So suppose we have a crust, here we have a earth crust, and from this crust we have, let's say just beneath the crust we have an earthquake, and when there is an earthquake there is a release of energy in all the direction. So suppose the earthquake is taking place here, so there will be a release of energy in all the direction. So energy will release, energy will radiate in all the direction. And similarly, this is what the P wave, this one, what the P wave, here we have a P wave. Now you will say that why we have a propagation in this way, why the propagation is, this propagation is not in a straight line. It's because, I hope you remember, I told you that here we have a different densities of rocks. Here we have what? Different densities of rocks. And it's because of the different densities of rock, what is happening here, that when this P wave is passing, suppose the P wave is passing in this way, straight manner, then the density is changing. When the density is changing, it will take again a straight shape. Then when again the density is changing, it will take a shape like this, it will appear like a curvy shape when we are talking about at a large scale. So it is straight, it's supposed to be a straight, but it's because of the changing density which is here, the density which is here, the density which is here, and the density which is here, then density will be different. Yes or no? It will be different. Okay, so here the density will be different, here it will be different, here it will be different. So when the P wave is passing through the different density rocks, its path will change because it will have a characteristic same as that of sound waves, bend and refract. So here we will have a same characteristic. Yeah, we have a same characteristic. That's why we have a curvy kind of shape instead of straight line. We have the same characteristics as that of S wave as well. So this S wave will also have a kind of this curvy shape. It's because changing density. See, we have a different densities here with respect to this particular layer. We have so many different densities. Here we have a different density, here we have a different density, here we have a different density, different density. So when we have a different densities, obviously the energy which is passing, seismic energy or seismic waves which are actually passing, they will either bend, they will deflect from their path, right? That's why it appears like a curvy shape. So if you see P wave, so P wave is like this, and I hope you remember the structure of our earth crust, mantle and core. So here we have a crust and here we have a mantle. For example, let's say this part is mantle and here this part is basically core, and I hope you remember that even in the core we have a different kind of categorization. We have outer core and then we have inner. Means different density is there, different density is there, different density is in mantle, different density in crust, even different density will be there in the upper mantle, lower mantle and middle mantle. Density will be there in upper core, middle core and lower core, right? So we have a different density, that's why it used to appear in this particular way. Now second thing is what, that when if you see the P waves, so pay attention, you have to see P waves, the pattern of I'm highlighting that. So this is what the P wave. Let me. So here we have a P wave. Have a P wave. Here we have a Here we have a P wave, and when there is a change in density, we have a liquid state outer core, its path would change, and again when it is actually, here we have a straight line, here you can see we have a straight line because we have a almost same set of density. Again the path will deflect because we have a inner core is solid, so path is actually curved, then it is straight again, then the density is changing, that's why the path is becoming curved again. It's because of the changing densities, because of the changing densities. P wave is able to pass through all mediums: solid crust, asthenosphere, solid mantle, outer core liquid, inner core solid. It can pass through all the. Now, how we come to know about this pattern? See what happened. There was a one place. Let's say we have a place called. Suppose we have a Delhi here. So in Delhi, there is an earthquake. So what geographers did, that they placed seismograph. Seismograph is basically a device which actually receive the seismic energy, and seismograph is the same device which used to measure the intensity of earthquake nowadays. So what geographers did, they placed seismographs on the earth's surface. Okay, placed what? Seismograph on earth's surface. Then they find out that when there is an earthquake in any part of world, the seismic energy is feel on the surface of earth. Yes, with a varied intensity. Okay, so based on this kind of aspect, we have concluded this pattern. All right, so we have certain seismic stations, we have reception, or we used to receive these waves at seismic station, that's why we used to record it in that same way. Moving ahead, now pay attention to S wave. S wave, I hope you remember S wave, S for solid. S wave can only pass through solid mediums. So here if you see, we have solid mediums. Which solid mediums? Crust and mantle. In core, especially in outer core, you won't see this particular S wave because S wave cannot pass through liquids. Okay, so it cannot pass through liquid. So here in the outer core, you will see that S wave is absent. Whereas if you see on this side, so that is the part of mantle, isn't it? Okay, this part of mantle. So in the outer core, S wave is not. It means what? That outer core is, because S wave cannot pass through liquid. That's how it has been justified. Outer core liquid, because the S is not able to. It's because these seismic waves are deflecting from their path. It justifies that yes, our interior would have a different density of rocks, and the different density of rocks would increase when you are moving from surface towards the center part of our earth. The density is changing. If the density is greater, the speed of these waves will also greater. If the density is lesser, the speed of these seismic waves will be lesser. Okay, so based on this pattern, we got to know that crust is solid, mantle is also solid, and core, outer core is, inner core is solid. Now you will say that why there is no S wave in inner core? It's because this outer core is not allowing. It's because this outer core is not allowing. It's like a Venn diagram. In CSAT you will learn about this, that this is what the barrier which will not lead to the entry of S wave. If the S wave are not here, then how come they will be present in this particular area, especially in inner core area? Okay, so this is how we have this kind of S waves propagation. This justifies as yes, the structure which we have discussed, crust, mantle and core, it used to be in that way only based on this particular. So seismic waves speeds change as they bend, reflect, encounter with a different material density of layers. Right? Now, let's see one more aspect here. As the S wave can only able to pass through the outer core. Suppose if I draw a line here for one particular chord here, actually shows the outer core boundary. And if I draw one more line from the inner core, what's the surface of Earth? So you will arrive on a one pattern. So this is what a one chord which is being actually drawn from the inner core towards the surface, from the outer core boundary towards the surface. So we have a one region here. This region is there where you won't see S wave. Here you won't see S wave. So this area which is extended from 105 to 105 here in this case, this area would be under the S wave shadow zone, because S wave is not present in this area. Why? Because we have a boundary of outer core, and when you make a boundary of outer core in this way, so this boundary of outer core will lead to the demarcating of the zones, which ultimately becomes watershed. Similarly, if you see the inner core here, so this inner core is also having this angle with respect to a plane, and this is become what, 140. In NCERT you will see it is 145. So here we have a plane. Suppose, see guys, here we have a one. This is our plane. Here the earthquake is taking place, and from this point we have what, radiating of energy. So this would be 105-degree angle, this would be 105-degree angle, and this angle, another angle is actually being drawn while taking a reference of the outer core boundary. So that's how we have 105, 105. From this plane we have 105. With same, from this particular plane we have 140-degree angle. Okay, from this plane we have what, this is the plane. So from this plane we have a 140-degree angle, and this 140-degree angle is actually under the confluence, or it is making a one chord with inner core. And inner core is what? Inner core is basically solid. So S wave shadow zone is extended from 105 to 105 with this particular. Similarly, if you see P waves, so we also have a P wave shadow zone. It's because of the change in the path. If you see this region, which is between the 105 140-degree angle, in NCERT it is 145, it is somewhere it is written 143. So just make a some sort of adjustment accordingly, that we have a 145-degree. So if there is an angle from this particular plane, okay, this is the plane. So from this particular plane, if there is an angle of 145-degree, and here we have a 145-degree, so this angle, this region would be the area where you won't see P waves. This would be the area where you won't see P waves. It's because this is the area which is actually demarcating the inner core and outer core boundaries, and the chord is actually being drawn on the earth from those sections. Okay, so it's because of this we have a kind of shadow zones. Shadow zones are the zones where on the other part of earth you won't see P waves, you won't see S wave. Okay, here we have, you can see we have a S P wave shadow zone, and this is completely being known as S wave. The S wave is completely absent here, P wave is completely absent between 105, 140 or 145 as per the NCERT. This is what. Okay, so on the other parts, you see we have a P wave. So based on this seismic study, we used to say that what is the possible arrangement of our interior of our Earth. The very important part, entire interior. I hope you have a have to make a plan. You have to make plan. You have to make a plane. Okay. Let's say we have a plane like this, and this is what 105 angle with respect to this particular plane. With this respect to particular plane, we have a 140 angle. Okay. So the epicenter, we will see in earthquake as well, that wherever we have a releasing of energy, that will be called as epicenter. So epicenter should be on that particular plane, and when we have a plane in this way, you see the angles. Another way of these angles are like the lines are actually drawn with the outer core boundary, and lines are actually being drawn with the inner core boundary. It's because the density difference of outer core and waves will not going to pass, and we have a one pattern. That pattern is what? Solid, mantle solid, outer core liquid, inner core solid. So based on this seismic study, have a clearly